Hello? Hello? Is this thing on? Is this thing is working? How is everyone doing? Doing well, I hope. All right, I'm gonna get a couple things open, get some music playing, and I'm gonna start poking at this calculator some more. Um, Actually, I got a flash drive to grab. 1 second. Hey, what's up, Pingu? Pingu-fent? Is that like a penguin elephant? Man, I started without my mouse too? What the heck? Okie dokie. I gotta keep an eye on my cats, make sure that they're not licking each other because they just had surgery. Oh, if I step away to go yell at my cats, that's probably why. Let's see. Do, 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 do. All right, let's get our calculator out. And I've got some new documents that I want to take a look at. Where is it? This thing, and where'd it go? Oh, this, I'm blind. Okay. All right, so I found this. 1 second. Sorry, cats are already causing havoc. So I found this, which is kind of the design document or engineering manual for this series of chips, the TMS 0100. This little dude right here. Whoop, whoop, whoop. That guy. Worst lighting ever, but anyway, this is going to help me figure out how to diagnose the clock on it, and maybe a couple other things like the keyboard matrix. But it confirms a couple things. One is that, where is it? The actual pinouts. Right here. So says the TMS-0100 NC is mounted on a 28-pin dual inline package. And importantly, it says pin assignments are the same for all standard versions of the TMS-0100 series. So we can know that even though our TMS-0115 is not directly listed in this document, the pin assignments are going to be the same. So we're only probably going to notice some differences in like the way that it handles the font or the way that it handles the keyboard matrix, depending on what types of keys we have available to us. Which we can figure that out later if we have to. But I thought this was a nice document that goes into more detail about this actual chip, calculator on chip, as they call it, or COC, a calculator on chip, right? Oh no, is that your childhood screen name? It's funny how they kind of like grow with you and move with you. So what I want to do with this specifically is kind of look at the clock timings. I haven't really investigated the clock circuit on this thing a whole lot, but I would like to figure this out and make sure that our chip is doing what it's supposed to be doing clockwise. So, and I think to do that, I'll have to power it up. I'm going to probe it with the scope and see if I can't see what it's doing. Move that up to the side. And just make sure this is at 6 volts. Oh, I need to get the breadboard stuff going. I don't have that going yet. Normally I have that running, but give me that. Boom. Get out of here. Oops. No, nothing. I'm gonna get distracted by this for 20 minutes before I get started on anything else. Probably has an update. Oh, you know what? Probably right. All right. And then let's do. Wow, my code must just not be working at all. What is the deal with that? What, kitty cat? Now you want out? You sound so pitiful. Right. Well, let me get some music going and I will start messing with this calculator. Really what I want to do. I'll let my cat out now. Okay, so this thing's hooked up to, or configured for 6 volts. And turn it off. Our negative is right here. Positive is right here. And then let's go find our legs that we need for the clock signal. Is that pin 1 up here? No, that's ground. Pretty sure we had it over here. Yeah, clock. I just want to double check, make sure that this lines up with this too. VTD, VGG. Yeah, these are all, they should all be the same. Same pinout. All the way down to 11. And SA up to SP. Okay. Hey, what's up, Julian? How are you doing? So this pin, I want to get a probe connected to that. Where did those go? I need my probes to actually short the thing on. Basically flip the power switch on it, right? And then that'll do that. That'll flip the power switch. Where did all my probes go? What the hell? What the hecky? Is that a sentence you figured you'd be hearing today? Where did all of my probes go? Oh, that's right. I've got them over here. I had these for... I was trying to set up a hardware glitching lab, and I want to mess with that a little bit more, but the I think the amount of work required to get the jumper list to have like really fast switching is a little bit more than just taking an off-the-shelf like Raspberry Pi 2040 program and like flashing that to one of these suckers and using this to do the glitching for you. But what I think I want to do is have this thing wired up to the jumper list so that I can send commands to this and then basically use the jumper list as like an orchestration kind of thing. Maybe. Who knows? We'll see. But I will mess with that later. But at the moment, I have to do more research as usual. But I've got my probes. These need different connectors. That's okay. different jumper wires. I've got jumper wires for days. There's one. There's one. Oh wow, from Argentina. Awesome. How's the weather over there now? Is it hot yet? Okay, I don't need these. I don't need those. These will all be useful. I really only need one of these though, but that's fine. A little organization. And we'll take this for a clock signal. This is going to go on the first pin up here, as seen in the documentation. I think that's got a good grab. Yeah, sure. And then I want to share a ground with this in my scope. So where do wire? I'll do this one. You know, use a different wire than red though. I'm not sure it'll really matter that much. Just visual. Okay, and then I'll plug my scope ground up. Turn this sucker on. And what we're doing is we're hunting for this clock signal and see if this clock signal is actually on. To be honest, I probably should have checked this a long time ago to see if the chip's working right. Alright, so I've got that plugged up. Alright, and let's go ahead and turn on our bench supply at 6 volts. And bring this out. What's it say? It says something about the clock cycles on here. Basis for the timing is the external clock applied to the device. Nominal frequency of the clock is 250 kilohertz. A digit time is equivalent to 13 state times or 39 clock cycles, nominally 156 microseconds. I mean, realistically, I'd expect this thing to be going back and forth, right? At a max of 7 volts. I wonder what the operating voltage for this thing is. Conditions, clock levels. High level is VSS maximum. And VSS is voltage supply, which is going to be 6 volts. It's actually going over 6 volts, right? I mean, that would seem problematic. And clock level low is VGG. idea. So maybe there's something up with the clock circuit. Or maybe the chip is burnt. What are the chances that the chip is burnt? That's not possible, right? Okay, so I guess what we can do now is test the yeah, of course it's gonna fall off. We can test the transistors that make up the clock circuit and kind of figure that out. So I was trying to map this whole sucker out. Still am. But the clock circuit, I believe, is up here. This is the clock generator. And so this is going to be this transistor right here. This one and this one are these two transistors. $4,700K resistors, 33. The problem is, I don't know what the hell I'm looking at. So I'm not sure I can actually, like, troubleshoot this, but I believe this is, like, a form of, like, astable vibrator. Is it multi-vibrator? I don't know. Two transistor clock. Two transistor toggle flip-flop. I've kind of got sort of a printout of what could be this. I could find it. Oh, there it is. So this doohickey. I think this is kind of what we're dealing with, sort of. So we've got our two transistors, got our capacitors. I don't know if our schematic, on ours we have ceramic caps, which I believe are these two dudes. Where did Krita go? Yeah, that's these two doohickeys down here. So this is our clock circuit. That's the clock 1 emitter 2. Goes to that one. Yeah. I think what we're dealing with is basically this circuit. I can try to... Do these have to be polarized caps? Two cross-coupled transistor switches. So let's go back to our circuit over here. Maybe we can try to make sense of this compared to how it's actually written in another multi-vibrator circuit. We can also check some others, like look at some docs. This is using 2 transistors as well that are doing the backwards linking, I guess. Oh geez, this is a lot of learning that I have yet to do. Yeah, so that makes me wonder if we're not getting a clock signal across N1 where it's supposed to be, then is there something not working right? I'm getting warm. Huh. Okay, so try to dig through this. So, potentially dealing with a bistable circuit. It says that bistable circuits, when you turn them on, you have to consider each state. Let's see. Yeah, so I guess we have to analyze our circuit a little bit more. I kind of want to double check it and make sure that it's right, and maybe kind of reorganize it, because right now it doesn't make any sense. So let's go ahead and double check this, and we will see if everything is working fine. I'm going to power this off. Because I believe I will need to probe stuff. And those are those C641 transistors, which I believe I have the box for. JE850U. I guess I don't. It's probably still in the C641. Oh, do I not have it? I didn't pull that one out. I guess not. I think I found this document. After I'd done the clock circuit. Maybe that's also a good reason why I should go back to it. Is it C641? 64, no? Maybe they don't exist in this document. I thought I had these documented. C641. Oh, you know what? It's because they're not Matsushita. Okay. I'm not a robot. The malware button. Okay. I believe this is what we were looking for. The little image. Yeah, where is it? Let's see what icon it was. Hachi? So there's the Matsushita, one that we've been dealing with right here. Hitachi, yes. It is exactly what it is. That's the symbol. Hooray! Okay, let's save this. There's an NPN. And that is going to here. Plymouth. Okay. This is what we have now. We have our emitter collector base. Hey, Purple. What's up? Sorry I didn't notice when you got in, but how are you doing? Collector to emitter voltage. Oh, those are max ratings. Emitter to base voltage. Okay. I guess could we plug this up and measure the transistors for the clock circuit, maybe? Just to see what those are doing. Maybe those are doing something. Oh, gotta get our ghetto power button going. to measure these guys up here. I rely on my handy dandy images. Board bottom. Okay, so these three up here. So that's something I'm not too sure on, the packaging of these. If you look, these are the kind of boxy package transistors, whereas these are kind of the round. These are Kiki transistors, and these are Booba transistors, okay? And is the side with the slope, is that considered the flat side of the TOS92? This packaging, or TO92? Is that considered the curve, the Booba edge or Booba side of the TO92, or is that considered the flat side of the TO92? Who knows? Emitter, collector, base. So collector's in the middle, emitter's on the outside, base is on the outside. So I guess what we can do is we can probe the this one? Emitter? Is that square post? No, the square post is on the other side. Oh. Square post on the inside. So the PCB, the pads on this thing, I've seemed to notice a trend where it seems like the emitter, it's either the emitter or the base pin on the transistor has a square pad. It seems to be pretty consistent across this board. So I guess let's I don't know if I want to do it with that. Yeah, I guess I'll just clip it onto the back side. Okay, just do this. That'll let me test this pin specifically. So and we'll turn this sucker on. Oh, my ground isn't connected. That's what that looks like. That looks like what it looks like when your ground isn't connected properly. That is not gonna grab. Okay, hold on. So what are we looking at on the scope? Is I need to get the scope software going again so that I can have that up on the stream instead of just a janky camera view. I guess that kind of worked. So this one's showing max like 300, 160 millivolts. Let's go ahead and clip to the third pin over there. Maybe I can get this without frying anything, right? By frying anything, I mean dropping my ground pin. Okay. This one is a max of 1.6 volts. Alright, so because our docs say 156 microseconds is a digit time, 250 kilohertz is the frequency of the clock. I'm just gonna leave it at 200 microseconds on the scope and not touch it. Oops, back to 2 volts. So that is sitting at 1.6, 1.8. And then I think this is the base pin. Lost my damn ground again. This sucks. What a horrible ground connection. That is sitting high at like 7.5 volts, which doesn't seem right. I mean, that's VSS, right? Where's VSS? How can I probe that? Oops. This. Oh, there's a part on the board that says VSS. Ha ha ha! Right, that's gonna be this little doohickey right here. So I can probe that. Just do the multimeter real quick. Oops. That's 7.18. I mean, the scope says it's higher, but I don't know if the meter's actually even that accurate. The docs, at least this document, says that I guess the issue is that I'm not seeing any clock signal type looking stuff going on with these circuits. So like this is the clock pin right there. Which I should be seeing that go up and down, right? Let's see, hold on. I can get a hold of this. Okay, that's a way better ground connection. See, all I'm getting is just a solid voltage on the clock signal line, or the clock signal pin. See what else? Am I missing pages? I feel like I'm missing pages out of this. 28 pages, right? No? No, okay. Base characteristics. It's mostly just about the keyboard. I mean, this is nice. Substrate supply operating voltage is 7.2 nominal, 8.1 max. So 7.2 nominal is what it's supposed to be running at. High voltage. Maybe I should make sure that the supply voltage is actually making it to pin 28, right? I guess that would be a good idea. .2. So the supply is getting 7.2. It says clock input voltage range negative 20 volts to 0.3 volts. Is it bad that this thing is cranking out 7 volts to the clock cycle or clock circuit? The max is going to be VSS. Nominal is VSS minus 0.5, right? Here, I've got the wrong thing up, like always. Classic. Yeah, so let's see, these electrical characteristics. So our supply voltage, negative 20 volts to 0.3, VDD, VGG, which pin is VDD? Pin 14. So, substrate supply, drain supply. And that is 0, right? This one VDD. Okay, negative 20.3. That seems to be right. That's a drain. A ground. Our ground is 1.31. GG. Maybe that's why. It's our gate supply. So is that supposed to be negative 7? I don't understand this. Oh, this is maximum ratings. Oh, and they're with respect to the SS substrate. Okay. Guess that makes more sense. VDD is voltage reference. Okay. Where on the board is that? It's marked somewhere, I believe, right? Or no? I guess that's just this pin. Okay. Lifted to VSS. Ours is what's going to be right here. -7. Okie dokie. Flow running, that's just all kind of functionality. These are really our most valuable. Oh, this one's kind of nice. This one corresponds to which segments. Okay. Yeah, I still don't think our clock signal is working. Some oddities with the board in terms of like troubleshooting to get this thing working. Our clock signal is just high. That's reading high at 7.2 volts. And then our ground, or VDD, our drain, is 1.37, and I think that's not supposed to be 1.37. I think that is supposed to be this guy right here. Is our reference, should be 0. Maybe there's something in the path from ground that's not, or from the drain that's not going to the negative terminal, maybe? Who knows? Definitely not me. But I kind of want to investigate this clock circuit. Maybe see if I've got this written out properly, and then also test it and see if it makes sense. We can maybe throw it into like a circuit simulator or something and see what we should be getting on some of the outputs. But I guess I also want to figure out which of these pins, which of these guys, because this is going to be our, I believe that is our base, right? Hold on, look at this thing. I believe this is our base, and then this other one is our emitter, right? No. You would think that just probing around on the board, I'd be able to find a clock signal, right? If there was one. If there ever was a clock signal that ever existed on this board, would I find it? I don't think the clock signal is working. I think that might be part of our problem. In fact, I think 1 second. Let me go see if I've got something available to use. Alright, let's see. I haven't done this yet. Probably should have from day one, but let's see if the thermal cam shows anything on the board heating up. Although I doubt anything on the board would really be heating up super bad, but we'll see. Oh, there is actually a part. I don't know if you guys can see that. That looks pretty hot to me. I kept feeling that when I was touching around for something. Is that a broken, like, Schottky diode or something? How about if I turn it off, let it cool really quick? Definitely looks like it's the one on the right. Yeah. Yeah, I don't think that's good. I don't think it's supposed to be doing that. How do you test a Schottky diode? Kind of thing? Can you test a Schottky diode? Let's find out. How to test a Schottky diode. 2 T's. Should show forward voltage at a relatively low current, so maybe 250 millivolts versus 600 or so with a regular diode. In the opposite direction, it should show over range. Of course, it needs to be removed from the circuit for this to work reliably. Huh. So maybe if I test it and it says that if it squeals at me and says, okay, your shit's actually shorted, then we'll know. Put it in diode test. Our diode is this one right here, VSS2, whatever that is. Test both of these. Okay, so I'm getting over range that way. Let's reverse my probes. And I'm getting, what is that, 791? And this one I'm getting over range. No? 638. I was hitting that other pad. Huh, okay. That's nice, look at that. Well, I don't think it's broken. Because it would show open circuit on, like with both, yeah, so here, let me get this on the thing for you guys. I think 700, 800. And it's 630. I don't know if that's good or not. It doesn't show an open circuit on either way though, so I don't think they're directly bad. They do look like they're dissipating some heat though in the thermal cam. Okay, what are those for though? That's these two Schottky diodes for the VSS going to these capacitors. That's all of this going down here. Over here. That's our whole VSS rail. I don't know why it's getting hot though. Or what would cause that. Or if that's normal. Yeah, it doesn't really tell me anything about, it says I'm supposed to have a block diagram, but I don't have a block diagram. What is that, page 2? Yeah, I'm missing page 2. Block diagram. Right, so I'm missing page 2 as well. No, that's the CMS 1000. I don't want the 1000. Get out of here. You know, I guess that's what I get, huh? That's all I get. Hey, Tibet. How's it going? Nice seeing you again. So this clock circuit, let's double check. I'll stop fussing over this stupid PDF that's missing information or missing all this stuff that tells me what I want to know. So Was I doing clock circuit? Yes, clock circuit. Is this sucker down here, these blue pins. Let me hide the VSS. I'm doing pretty good. It's a Monday. Alright, so here's our clock circuit. Let's go ahead and dial in on this first one down here, this dude. What about your Mondays? Got you all messed up? Probably work. I'm guessing most people have to go to work on Monday. Is the commonality. So this is... Let's start with the first one. Let's start with this one, C6411. And I believe that is going to be our emitter. Okay, and maybe I need to come up with like a color scheme for emitter, collector, base. TDI? What is TDI? It's right here, TDI or TD1. When you say this, are you referring to something you're working on, or are you talking about this calculator? This tedious calculator? I will be happier when this thing's working too. Yeah, the calc. Yeah, it's a bit tedious, but I'm excited to get it working. So I'll do emitters are going to be green, base is yellow, right? That's the base. Or sorry, collector. And then base, we will do purple. Okay, so base, collector, emitter. And then let's do that for this one too. We will get this dude right here. Right, so that's the base, that's the collector, that's the emitter. It's interesting. Does this jump over to here? What is that? I think it comes from this resistor right here. Let me check that in a minute. So this is going all the way over here, isn't it? Like right here, I think. Do a continuity test just to confirm. We're going from this one right here over to here. Oh, no, the bottom one. Sorry. Bottom one over to the second one. Yep. So that's got continuity between those two. Which means that it is going down to here. Oops. Like that. And then if we do this, exactly where that's going. What is that? That's just the straight up clock line. Okay. So this emitter, this one's actually going to the clock pin, or wait, base collector emitter. So this collector is going to the clock pin. Right, that's the clock pin. Yes. Or no, this is the clock pin. Did I get this wrong? No. No, 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 no. No, 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 no. Yeah. Okay. So that is the coffin. That is VSS. I'm not crazy. I'm crazy. It throws me off because I've got this image mirrored so that it works. So it lines up with the top and the bottom. That is the clock pin. So this is the clock pin, which goes to this collector. That's interesting. Let's look at transistor clocks, right? So this has this is the base, that's our collector and our emitter. The collectors get fed from the base of each other, or from the capacitor that gets drained from the base. So when this one is on, this capacitor is draining over into here, or the opposite. When this one's off, this capacitor is draining over into here. Go through C12 towards the base of Q10. Yeah. Cutting off Q11 will lower the amount of current passing through R41. Right, where's R41? This one. Decreasing the voltage drop across the resistor that causes QC0's voltage to rise slightly. I guess this is clock cycle. Negative clock cycle. This is where you actually feed out of that to get the clock cycle. Sometimes I'm live on the weekends. I need to come up with a schedule. I'd like to start doing this a little bit more regularly. And I feel like coming up with a schedule would make that a bit more appealing to some people. Alright, so let's maybe take a look at this. So this is our clock. And I don't know if power's supposed to be, I don't know if we're supposed to have a current flow from this clock pin into the clock circuit, and then that goes to the driver pins, because this diagram was telling me, this document was telling me that the way that the displays are driven so 13-digit blanking for calculator applications, digit scan terminals, was it? Where did I read that? Digits are displayed in scanning mode, so any digit is displayed for 1 D time and displayed again for 1 D cycle later. A D cycle is equivalent to 11 D times, that's 1.72 milliseconds. A digit time corresponds to the amount of time during which each digit is displayed. So maybe what we're seeing is this clock signal, because this clock signal goes out to the driver pins right here. And goes to this resistor network. Where is that? RN. Somewhere. Anyway, it goes to this resistor network, right? The clock signal runs to this resistor network through, what is it, this pin right here? Yeah, this purple one. Collector. This base collector emitter base. Maybe the... Yeah, I'm not too sure. What I was imagining is that this clock signal is fed to this resistor network, which then goes to the individual pins that drive the display up here, and so that's what keeps them on for X number of cycles or something. I think maybe that's what that's for. Oh, gotcha. I feel you. Yeah, I can try to... I'll work out a schedule. I think I might put a poll in the Discord or something about what days people are generally free, because I would like to stream when people are actually interested in watching. So if you're in the Discord, I'll throw up a poll. You're welcome to vote in it, but I do have it noted that having like a weekend day would probably be pretty cool. I think the breadboard's all messed up, by the way. I can't figure out why my code is broken. It doesn't like, or maybe I'm just doing something bad. Let's see. Yeah, it's not playing nice. Oh, you know what it is? It's probably, I'm not telling it the right port. Yeah, see, that's not the... There it is. Hey, there it goes. Yeah, I just had it pointed to the wrong device. I didn't spend a whole lot of time troubleshooting it when I first started the stream. wonder why that is not working. I don't think I set up the boot file. Oops. I think that's in there. See, I don't have that in here. Changed it to give, which is it? Magic 8 Ball responses. Because that's fun. Fortunes, nothing fortunes file in here now. I don't think... Oh, I have to restart it. I forget. I forget. You have to disconnect and restart. Yep. And it's probably on a different device now. ACM 10. ACM 9. Hey, okay. Jeez. How you do that? I don't think it works. I don't think the boot.py is working. I think I have that over here. Oh. Do-do-do. Bruh. Does not like Device has been lost. Connection to device has been lost. Right, I will restart that. Like 3? No, it doesn't like 3. We're at 6. You like 6? No? Don't like 6? Oh, 4. There it is. Device 4. Okay. Boot.py. Oh yeah, see, there we go. From onwards, import. Let's see what this does. That should do it. I'll save that. File save. Let's see if it actually fixed this up now. ACM6. It keeps jumping around all over the place, so I need to figure that out at some point. So I didn't do anything. It does respond to that. Can I do... See, what is it, read to GND, right, yeah. I don't see it actually doing anything for that. Okay, that's fine. Either of these. I know it's 6. What are you freaking out about? Okay. Eight ball is not defined. Does boot.py not work? From fun words, import 8 ball. Okay. From fun words, import. Can't perform relative import. Dot fun words. Is it Python scripts dot fun words? Oh yeah, there we go. So that works. Python underscore scripts dot funwords import 8ball. Save that as our boot.py because it does not like doing relative imports. And we'll restart this. Test it one more time and then it should be good. At least until it breaks again. So 8ball, should be able to just do that. Yep, and then it says without a doubt. My sources say no. It's decidedly so. Make that larger, right? OLED print is... Use large text. Small scrolling text. 1 is normal. Okay, let's do 1. Wait, use the default size. Oh, defaults to 2. Okay. Oops, ACM 10. No, is it not ACM 10? ACM 9, oh my god. 8ball. Alright, cool. And then I can come over here. Let's actually disconnect that. I don't want it interfering. Over here. Start that on ACM. Is it 9? ACM 10, right? 9. It was 9. And then I can do 8ball. It should do it. Yay! Yeah, I couldn't imagine doing software engineering for your job. That sounds awful. One of the best things about my previous job was that all the code that I wrote was for myself. It wasn't enterprise code. So that probably explains why my code is so shitty all the time. But it's more fun to write stuff that, you know, isn't enterprise mandated, I guess. Anyway, I have to go to the bathroom, so I'm going to step away for just a couple minutes. Go to the bathroom, take a quick break. Alright, and I will leave you folks with the breadboard. Hopefully it's not blurry. There we go. Alright, be right back. Hello, hello. Hello, cat. You're walking across all of my stuff. Yep. Oh my gosh. Hello. End of the calc is near. I'm afraid not. I wish. I wish I knew enough about it. What I think I want to do now, though, is I kind of want to make the clock circuit. That makes any sense. I kind of want to take the clock circuit, either the one that I have on the schematic, either this one that I have right here, pop, 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 which is just like a regular NPN transistor vibrator, multi-vibrator circuit. It should like generate a square wave, like a clock signal, which is what I think I want to do, so that I can learn a little bit more and understand more about the actual clock circuit on this thing. Or I could just go through and start mapping more of this stuff out. I think I should confirm that this is all going to what it is, and then maybe make this circuit. I could produce this thing and see what this does. I supply it with a certain voltage or something. So, I don't know. We will see. Lots of things to do. Plenty of things to learn and test. I do want to confirm, though, that this circuit is accurate. Because if it's not, then it's just going to be problematic later.
You'll be mine.
This middle pin of the top one. Okay. Figure out where this middle pin goes. This middle pin goes down to this squiggly trace? No. Yes. Yes, this squiggly trace down to here. This resistor. So we'll stick this sucker right here. Or if that's confusing or not. Darken it when it goes through a resistor or something. I feel like that's just too much. That goes to there. Does it also flow back to... Get a one right there, right? Yes, it also flows backwards into here. Means that these all are like that. And this is something that I was trying to figure out if it's a good idea or a bad idea to like kind of distinguish when these are going through resistors. So maybe what I can do, let me label these. So I have a thing for, no I didn't. Get a new one. This is going to be resistors. Oops, I did that wrong. I'm gonna make a new layer as soon as I do this. One. What do we want this? A brown color, T1. Brown orange. Burnt orange color. Oops. Oh. Like that. This is sisters. T1. Bold? Yeah, I'll have it as bold. I think that's what I did with the other ones, right? Those are bold? Okay. And let's do T2. And this is so that I can keep track of them in the schematic. Well, have a good one, Tibet. See you later. Bye! hopefully by the time you see me again, I'll be done with the calculator, right? Alright, T1 and T2. And let me go into this. So I don't know which one of these is which. I guess I can name it Q. Is that what all these transistors are? The Q something? Oh, that's C. C something. C14, whatever. I don't know, I'll relabel them. Yeah, here's the other Qs. Alright, so CKQ1 and CKQ2. Or, how about I do this? I do C, what is it, the 641? 641? 641, 2. C641. I think I like that better, because then I know what type of transistor it is, or what the part number is. Remember, there are no rules. I mean, there's probably some rules, but I don't know them yet, so therefore there are no rules. Alright, and we've labeled this as 1, because that's the... I think this is the one that gets fed first. Let's see. No, it's actually this one, right? This lower one? I guess let's start with the base pin. Base collector emitter, or is it base collector emitter? Makes more sense that this is base, right? Where's my ground? Wait, that's VGG over there? Okay, so this is the base collector emitter. That makes sense. And then this one goes to our clock pin. I think this is the first one. This is the collector emitter, but I don't know. I feel like a clock circuit you would have. Let's go back to this guy's right up. I feel like with a clock circuit you'd have the output coming from the emitter, right? So they're measuring. No, that is the collector. Okay, and the emitter is going to ground. Oh, because the collector is being supplied from the base of the opposite transistor, and this one gets supplied from that. I guess it's, yeah, bloop. It doesn't go through that, it goes through the capacitor. Right? This guy's circuit says that they've got a system where the harder Q10 turns on, the more charge you pull from Q11's base, and the harder you turn Q11 off. Positive feedback loop that snaps a circuit into the other state. Basically, as long as the pulse is present, all of the current passing through C12 is just dropping through D10. So C12 gets dropped through... Here's D10. D10, this guy. Sure. Oh, these are diodes. Okay, so you're measuring it coming off of over here, right? Measure the base pin. So if I go back to this schematic that I wrote down, if everything is correct, and this is like a vibrator circuit, bistable circuit, whatever, we'll see that the base pin of the two transistors is where our clock circuit either comes from or goes to the chip. Is that an input? It's the clock circuit's an input, right, on this thing? Because you have an external clock, then internal clock? I don't know what it means by that. I do not know what you mean by that, old electronic wizards that wrote this tome. Oh, these are different state timings. Okay. Uses that for the... because this would be like for your segment driver or something, I think is what it was talking about. Okay, that's our external clock. External clock should be 250 kilohertz. Let's look at this. There's another one that I saw. Oh, I'm swimming in tabs. This is how it happens. This is how I die. I open too many tabs and I die. Yeah, because I think realistically this is what we're dealing with. It's like very simple clock circuit, this thing. Yeah, this right here. This is a very good document though. This is a very good write-up. Gets into the like Android and Ordroid. This bistable circuit. Q1, Q2, current A and current B. But they're pulling their output over here where it gets fed from the collector, not the base. Whereas this guy... I guess that's technically the same, right? That's the collector. Okay, so let's take a look at our schematic. If we have the collector going to the driver pins, and that's going to... This collector should also be going to the driver pins, right? Or to this clock signal? I think that's what it should be doing. let's try to redo this circuit. We'll redo this circuit over here, and we will rearrange it in kind of like the same way that you would do like a vibrator circuit, a bistable thing or whatever, like this. Wait. I guess, yeah, that's fine. I want the emitter at the bottom now. There we go. And then we do we have 47s and 33s, which, actually I'm just going to go based off of this one, 47 and a 33. The 4700 goes to, or the higher resistance goes to the base. Okay, so this base spin goes VGG. Goes VGG? What the fuck are these? Goes to the emitter. Goes to the collector. Yeah, I don't even know if I got that right. Okay, well, I'll just try making sure that we get it right. Double check. Starting with this transistor 1, which is the one closest up towards the corner. Actually, I want to do these the other way around. Where is that? This. Hello? Ah. Alright, so that's transistor 2, this is transistor 1, right? There. Boop, 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 boop. Okay. I think that is the correct order, because this gets fed from this clock pin. I don't know, maybe I have it the other way around. I guess the clock pin's supposed to be an input, right? Just do that backwards. Just undo it, right? Doop, 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 doop. Alright. So that's going to ground. Right, that's our base. Like our emitter. How does that get all the way over there to the ground now? Where's that connecting? Is this thing? All the way over to here? No? Did I just probe this at some point? I don't remember how I got that last time. It's interesting though how it has like a little minus right here and a little plus right here. What is that all about? Kind of hard to see where that's going, but it's definitely going under the board somewhere. Okay, so this one's actually going up to VGG. So this pin right here goes up to this thing. VGG. Very ugly. And then this emitter, or collector, sorry, this middle pin, right here on this one up the corner, gets fed from down here at this guy, all of this crap over here. So this is the collector, and then we've got our emitter, that green one. Alright, so this is our first resistor. Which is a... Are y'all ready for it? Yellow, purple, red, gold. Let's see, yellow. Is it violet? Yeah, violet. And 4.7k ohms. Which is this dude. 4.7k ohms. So we will say... I don't want to do that. Let's just rearrange this stuff. Let's go ahead and look awful. I don't know. Okay, whatever. Do it over here. So base goes to ground on T1. Okay. Later goes to this 4.7k resistor. Right? This guy right here. And then that 4.7k resistor goes to these three other doohickeys. Is this right here? We have another, is it another 4.7? Yeah, another 4.7, and then two of those orange gold 3300s. this is the 47. Do I have a thing for resistors? Ooh. Get one. Hey, what's up? Zebisnag. Linux Mint is pretty good. I don't mind it. I would say it's my preferred Ubuntu, I guess. Is it Debian? Sorry, not Ubuntu, Debian. The preferred Debian distribution. I think it's the XFCE. I can't remember which one I installed. Yeah, the XFCE one. It's gonna be resistor 1. And then we have resistor 4. Maybe I can make these smaller, but I don't know. Who knows? Hello, kitty cat. Okay, so let's start with resistor 1. This was our 4-7. Go to resistor 2. I've got our 4-7 and resistor 2. Using this R1. Oops. Ah, what is that? Out here, double click. I may need to rotate these. Oops. I don't know. I want to make this more readable, but R3 is a 33, R4 is also 33. R4 does the same thing. Alright, let's see where these are going, and then we'll make our decision on whether or not we need to reorient some of this stuff. So R2 is going to get out of your brush presets. I don't want anything to do with you. Oh, that's so much better. Does anyone else hate that whole, like, hold the thing next to, like, where you're scrolling and let the scroll bar do it? It's, like, the most not useful or functional feature ever. I hate that. It's my least favorite way to scroll through something. I feel like you should be able to just grab it and then mouse wheel while hovering over this scroll box. That's better UI, in my opinion, but whatever. the resistor 2 is going to a capacitor. That's this film capacitor, I believe. And then going back to a Schottky diode. Okay. So R2 is also, R2 is going to the Schottky and this capacitor, right? What that look like? Goes to this guy, or the board. Maybe I can, where is this clock? C6. Another layer. Here. Name this one R2. Maybe I shouldn't use the same color. The font UI is right. Okay, make it a little bit darker than that. Blap, blap, blap. So R2 goes to a Schottky. And then this capacitor. And I guess I can make a new layer. Hit C for film cap, I guess. Or just do C. Capacitor, this will be C1. I already have a capacitor C1. I already do. No. 6, 5, 4, 8, 7. Yeah, I don't. I'll do this as C1. Is it possible to use the keyboard button pad for another project? Are you talking about like the Stream Deck that I reverse engineered? You should be able to. It's just a matter of hooking your code into it. Honestly, I need to go back and revisit that and do some changes to it because it needs a bit of work. It's somewhat functional, but it needs a bit of work. I should use that as an excuse to learn Rust. rewrite the code for that in Rust or something. If you have questions about getting it to work, like specific questions when you get into the nitty-gritty of it, you're more than welcome to hit me up and ask. And you can hop in the Discord too. Throw a question in there if you use Discord. If not, don't worry about it. GitHub. Leave an issue or something. I don't know. That's C2 and C1. What are we going to use for capacitors? We use that orange color. That was not that orange color. Hello? Whatever, close enough. And because these are non-polarized, I will leave the colors the same. So C1, C1, and then C2. Oops. Make another one. Okay, before we get a little too carried away, let's go back into our schematic. So we've got resistor 2 going out into resistor 1, resistor 2 goes out to the Schottky, and then we have it going out to one of these capacitors, right? This will be C1. Oops. Oh, I wonder if my code's still running or is it broken? Ooh, it broke. Rip. So C1 actually goes to resistor 3. I didn't do R1, did I? R3 connects back to R1 after going through this capacitor, right? And where else does that capacitor go? Yeah, I'm not seeing it do anything else. This one at least. This other one goes like over here, fucks off to this thing up here, E2. So capacitor C1. Oh no, wait, here we go. Goes all the way up here to boom. So this capacitor, output of this capacitor, well, other side of the capacitor goes to R3, and then the emitter on T1. And then comes out to R3, right? Wow, really, KiCad? Yeah, that's totally a trace that I want. Get that. Jeez. Okay. Goes back to R1. Is that all of this? One goes to T1. What about this? What does this one do? This is the one thing that we haven't gone past the Schottky either. So let's follow up on R4. So R4 comes from R1. Is that coming off of... Oh, so C1. Wait, no. That's C2. This trace coming off of C2 goes to R4 and T2. I need to change that. Oops. And grow by 1 pixel. There we go. Is that any better? I don't think that's any better. Whatever. There we go. Now we can see that these are distinct traces for this capacitor and that capacitor. R4 goes to C2. And where the hell does that go? C2 goes back to R1. You know, that's a good idea. Um, haven't messed with it yet because, to be quite honest, I'm a noob at all of this stuff. But that is a great idea. I probably need to do that instead of using it in, doing it in Krita. How do we do that? Let's see, tools. Schematic sheet content. No, I don't want to do that. Let's see, I guess I could just look it up real quick. And then, what was it? C2 comes off of, it goes to R4, and then the emitter on T2. Oops. And I believe this is where it becomes a stable multivibrator or bistable. How do I make it your paths? Nope. I want to make it so that I can do a 45-degree angle. Where's that sucker at? .45. So this is where I do this, going up to here. Oh, nope. How about I just do this? Up. There we go. And then this guy on the same height. I don't know if that's better or worse, but whatever. There. See, this is making more sense with all the diagrams that I've seen about bistable circuits, or at least clock generator circuits. We've got these two potentials. They should bounce back and forth. So C2 goes to the emitter on transistor 2. And then it goes to resistor 4, which is right there. Gotcha. Right, now let's go back and look at... Well, R2 we'll need for the Schottky diode. C1... Yeah, whatever, we'll just turn all this off until we need it. And then let's see, we want to check out the base pin goes to VGG, collector goes to R1. Did I get that? No, I did emitter, goes to R1, alright. Because that's the emitter, right? Yes, sorry, the collector. This collector goes to R1, not the base? Yes. Okay. I wonder if it would be better to just kind of flip these. Wait. Whatever, I'm not gonna mess with that, it's gonna throw me off. Nitpicking. We're nitpicking again. And then the emitter goes where? There goes to C1. There goes to C1. Okay. Maybe I can just move this dude all the way over here. Yeah, I got them opposite sides of the thing, I guess. I don't know. And then let's check our transistor 2. This guy, we've got our base right here going to VGG. It's hideous, I know. This is what happens when you don't know what you're doing. And then our collector goes to... Oh, how's it? What is that? What is that over there? Get out of here, VDD. I want to see you using me. Alright, so this goes under the board, all the way over to there, to there, to there, to there. Right, is that our ground? No. It goes somewhere else, doesn't it? This goes to the... Let me see if those are connected. Let's see... Are they base to base? It looks like they are base to base. So we've got these guys, right? Yep, they are base to base. So those are connected or bridged. Which means that this ground go right here, over here. But yeah, there we go. So these two, from there to there. That's interesting. So, is this all just like ground potential for the clock signal? If that makes any sense? I really don't know. I think this might be the negative, like the ground potential for the clock signal that gets routed to other stuff like these, keypads, button presses and stuff. Alright, anyway, the base is going to our VGG and then our collector on T2, going to R4 and C2. Alright, emitter. Base, collector, emitter, collector. Already have the emitter. Where is that sucker going? So it is going over to the other side of the Schottky diode, which is kind of interesting. So this is going to this guy. And it's also going to the clock pin. Right, and then going to DK. This is our clock pin on the chip. Is a key. This is some other fucking resistor. What the hell is that? Resistor 5. We found resistor 5. Okay, resistor 5 goes all over the fucking place. This is going to this pin, which is... Where is that? This thing over here. Holy crap, I've got so many tabs. This one, ESS. So we will say that this transistor goes to, what is this resistor right here that hits VSS? Yellow, purple, red, gold. Yellow, violet, red, gold. So that's another 47. Or 4700K? Yeah, 4700K. So this is going to be resistor 5. That one is coming off of this. Right? Is on this side of the Schottky resistor. And then on this side of the pin, it goes to VSS. Say that is VSS. No, I'm not waiting. This thing's kicking my ass. I'm still not too sure what's going on with this thing. Alright. So that makes a little bit more sense. Maybe? I don't know. And nope. So I want to compare this. Let's compare it to, what is it? This guy's circuit. Here, 12 volts coming in. He's feeding like both of these at the same time with one resistor, but our circuit looks like it's feeding one of them. It could be feeding two. What does this go into? Base collector emitter, base collector emitter. Hey, thanks, Quantum. Yeah, feel free to check it out. We've got a Discord too if you want to hop in there and hang out or chat about stuff like this. Yeah, I'm still not sure how it actually makes that lock circuit. I think we're on the mark though. Because the base of this one, the base of these are both going to VGG. The collector getting fed from, okay, let's just follow it from the BSS. BSS is going to be our supply, right? So I went back over to this. Wanted to confirm. Here's the electrical characteristics. So the substrate supply, yeah, so this is going to be your positive 8 supply. VGG. Is going to be the negative of that, so that's going to be your ground. So I don't know, does that make any sense? I don't know if that makes any sense. I don't know enough about circuits. I guess T2 is the It's like the start of the clock circuit, because this is the one that's actually connected to VSS, to the supply. And it kind of loops through this one, comes through here. I guess they kind of just bounce back and forth. This doesn't make sense to me, though. I don't see why you'd have like a direct supply going to the clock line. Let VSS go. VSS 28. This guy. It all comes through here. Comes out over this way. Sorry, is that the other way around? Up over here, this is the flow of it. It's going through here. I think that's what it is. It goes through here. Regardless, these pins are our VSS. That's going to be our positive voltage. That applies this transistor right here. So transistor 2, that's the start of our clock circuit. I guess that makes sense considering the silk screening, or like the printing on the board. Make a positive right here and negative over here. Where is this going under that connector? That's kind of crazy. Where's that going? So this thing over here, underneath these two, this connection. I feel like I probed this at one point. I don't know, we'll try it again. Let's see. Just two. Wow, that's very difficult to get to. Let's do it from the side. Right here. Or 5. Right in between this resistor network, this guy right here is R5. That's this dude over here. Third from the right. On the bottom, this guy right here. I don't know what the hell that's for, but where that goes. to make it just detect whenever it stops and then restart that code. Maybe I can do that. Let's see. Little side quest. Jump on the stream. Get control. My handlers start YouTube. I think what we want to do is start YouTube listener again. Buffer. We'll just restart it, right? It is decidedly so. Let's see if that keeps it alive. Probably not. The code will still break, but... this goes over to there. Our R5. Wait. What is this again? That's our VSS. Right? Oh, this whole pin is VSS. That's right. It's VSS to that. I've got it wrong. Wait, and then clock. How does that get to the clock pin? Yeah, through the resistor. It's not directly connected to the clock pin. This goes to that, goes to that, goes to that. This clock pin comes from here to the... Is that the middle leg on E2? Yeah, that's the middle leg on T2. Oh, I guess that's what it's supposed to be doing. It's supposed to be like a normally high pin driven low for the clock signal. So this is actually syncing to ground alternatingly. And I think that's making the clock signal. I could try to simulate it. I think, maybe? And that looks about right. At least what I've got over here. Good God. What a mess. I don't have this part though, where it gets back, where it feeds to this resistor network. Let's see what that is, because this is coming from here. Oh, this thing right here. But I think this was different. I think, because over here I have this resistor network driver pins. That gives us our VGG, right? Or VGG? No. What is that again? The base pin from this one, from T2, travels under the board, goes to the resistor. Yeah, that one's not just going straight to VGG though, is it? No. It is from the other side because it is connected to T1, right? Let me make sure I get that. Yes. So the base pins on these two transistors are connected, so T1 and T2, these are connected on the other side of the board. Which puts this one going to VGG, right? How do I get from VGG all the way over to there? But how is it? Is it seriously running under the board all the way over here? What? Oh, no. It's over here. That's right. Holy shit, okay. VGG is not connecting from over here to over here. There's a path, like up here, that it's taking all of this shit, I think. Okay. It's getting VGG from up here. That makes more sense. And then those are connected to VGG from there. So ground. But then also, going out to whatever the hell that is. Oops. Goes out to a resistor, which is this boy. Orange, 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 gold. That's what our 3300. Right, that was off of that. Base pin. This is that. Over here to this 3300 resistor. And then goes to a resistor network. Wait, no, that's the same. Okay. Right? I think that's right. So I guess this gives like the, yeah, I think this is giving the ground potential for the driver pins. And then the driver pins are, is inside the chip being floated high for whatever reason or something or another. And then they get driven low for a period of time? I don't know. I don't really know what's going on inside this chip. It is a mystery. I think this makes a little bit more sense than what we had before, which was this. And KQ, I need to do that one. We've got like a, what is it, 3300K resistor coming off of that. This sucker right here. And that is going to, what is it, QQ? Right, this guy right here. Is going to this one. Because whoop, wait. Yeah, it's this guy right here. You see that was resistor 6? 6 here. K025? What it was? What do I have it in here as? KQ? KQ? Back to KO. KO. Alright. What is KO? Is it the output? Parameter input current on K lines, K input low. All other pins are ground. Okie dokie. Huh. So what KO is used for specifically? It's some keyboard matrix, right? Right here, KO, KM, KP. You would think that it'd go to like the others as well. Maybe that's the oops. Maybe that's the resistor network. No, because this goes through the resistor, and the resistor network is hooked up to the ground side of that. So maybe there's some other stuff going on the other side of the board? I feel like it looks like there's a trace running from here to there. Let me check that. Where is that? That is between there and there? This guy? Yeah, so this guy goes to that. Which goes to this first boy. If I do that again, it goes down here to this, right? Yeah. Yeah. Okay. I think that covers our clock circuit. Let's see, is this one correct? I have no idea. But I could probably take this and put it in a breadboard, put it on a breadboard or on a circuit simulator tool. See how this works. It should be getting driven on the board though, and I haven't seen that. I just see 7 volts supply. Maybe I can test the Schottky diode, because the Schottky diode is supposed to keep it from... No, that's like a backbeat thing, I think. I don't know. I don't know what I'm doing or talking about. Don't listen to me. Okay. And we've got 698 forward voltage. Or current, I guess. That diode works fine. Could we measure the resistance of the resistor network? That's supposed to be NTK22220K ohm. What is that, 220 kilo ohms? So if I check this, We're testing this guy, this little resistor network, or resistor array, whatever you want to call it. And that is this guy. And I believe this one right here, or is it this one? Do not think that I am probing this properly. Oh yeah, there we go. I was doing ground to ground. Maybe this center pin, and let's go back up to that. $220. Okay. I'm trying to try the some different probe tips. Let's see, really better. I like needle probes. Sort of sketchy. I guess actually I could just this comes off. I think so it'll be easier. There we go. Now you can actually see what's going on down there, maybe. I don't know. Camera's still a little too far out, whatever. But we're getting 220 kilo ohms, so the resistor is still working right there, which is good. I don't know, it seems like the clock circuit is fine. Maybe not, I don't know. We're supposed to be on the second one. If we look at the, we measure the collector on the second pin, or on the second transistor, that should be our clock out. So let's try that. Let's hook this sucker up. We'll probe some stuff and see if we can't figure out where our damn clock signal is. Let's see, we've got positive. And negative. You know, I guess that's how I damaged that other probe. Grabbed something a little too wide with it. Alright. Let's see if that works. It probably will not. I just want a nice ground to grab onto. Well, actually, maybe I have to connect it to... Because ground and VGG are different. Maybe that's why I'm not seeing a clock signal. let's try this little pin, this resistor leg down here. Oh, that's not right. I cannot connect that. I grab the VGG over here. Let me just grab it on this leg. There's a base pin down here that I can grab onto. And that's going straight to the base of our transistor as well. So that is this pin, right? If I check the... It is currently off. Let's go ahead and power it and see what happens, see if we fry anything. I hope not. 8.39 amps. Let's check our clock pin. Max of 6 volts. That actually is better than what I was seeing. I was seeing 7, right? That was interesting. Oh, you guys can't see this. Here, let me adjust. There we go. I'm just probing around on the board, looking for signals. I'm looking for this clock signal. This is the clock signal pin right here that I'm looking at. Maximum of 6 volts when compared to the VGG. Oh, 15 hertz? You seen a... No? What's looking for? Maybe I need to change my trigger modes. Let's see, menu, edge type triggering, slope. Oops. Okay, let's get both of them. Let's get up and down. See if it's auto. Yeah. Yeah, I don't know. I'm not seeing any square waves. I'm not seeing any clock circuits. Maybe these transistors are bad? No. Because you should be getting something through the emitter, right? Or in this case, the emitter is connected to ground, right? So the emitter's connected to a capacitor, which is connected to this, which goes back to the collector. Goes back to this collector. Yeah, so I should be reading on at least the clock pin some sort of clock signal, but I do not see it. Let's just do auto really quick. Yeah, I have some stupid setting. Nope. Oh god. What the hell did it do? Yeah, Auto didn't know what the fuck it was doing. Okay. I mean, I don't know what the fuck I'm doing either, so... Where's the difference? So maybe we need to, if we're not getting a clock signal... I don't know, we should still be getting a clock signal, unless these transistors are just borked? Which I guess we could try to... We could desolder them? I would like to probably maybe set this circuit up with my own transistors. These C641s or whatever they are. Frequency amplifier, high-speed switching. I can maybe find something similar to these. Let's see. C641 transistor. Input capacitance versus emitter to base voltage, blah blah. Yeah, that is. Alright, what is collector to base breakdown? Actually, let's see. Silicon transistor characteristics. I know, that's super generic. There's so many. Alright, AI overview, what you got? Collector to base breakdown voltage, maximum reverse bias voltage at transistor collector base junction can withstand before conducting significant current. It's a collector to base junction, but that's reverse bias voltage, okay. And I guess that's the same for this. I think this is on any base to emitter saturation voltage, right? Base to emitter. Wait, no, collector to emitter saturation voltage. VCE saturation. Minimum voltage drop between the collector and emitter of a bipolar junction transistor when it's fully turned on. Oh, okay. Minimum drop. I guess what I'm trying to figure out is, like, what is the minimum voltage or current required to turn it on applied to the collector? Oh, see, turn on time with the voltage. The collector? VCC, is that what that is? Five volts. It's typically 20 nanoseconds. Okie dokie. Let's see. I guess I can move on to a different part of the circuit. I can keep bashing my head against the clock circuit, but I feel like I need to address the transformer circuit, maybe? I don't know. Wow. it look good. Still working. Wow, the code is still working. Alright, I'm gonna take a quick break. I'll be back in about 5 minutes. BRB! Hello, hello. Is this thing on? Concentrate and ask again. Concentrating. Is this thing on? Most likely. Okay, cool. Wait, what am I going to do? If I, like, supplied an external clock to this thing, would it work? Or no? Could it be the capacitors in here? Like if I measure the... I don't know. But that's current. So you can't really measure the capacitance of these, can I? I need ideas. I'm not too sure where to go to test this thing. I mean, the clock circuit's definitely not working. At least I'm not measuring a clock signal. But is that because the chip is bad? Is that because this thing is bad and it's not doing stuff? So it says the clock level high is the VSS, nominal is VSS minus 0.5. And the supply is 6 volts. So I'm measuring 6 volts, so that's the max. And the clock low level is supposed to be VGG, which is the gate value, or negative gate, which is this probe right here. It's not the probe onto the battery, because that'll get you 7 volts or whatever. Am I just not measuring it fast enough? Is that what's going on? This should be the clock. But 5 nanoseconds and it's not doing anything. It's not... It would capture it with the trigger. It would absolutely capture it with the trigger on the scope. Maybe I should make my own clock circuit and just look at it on the scope. So, compared to the schematic of this is an NPN transistor astable multivibrator circuit. This one has VCC going to the collector. So you got voltage coming in, going to the collector, and then the emitter comes out, goes to ground. Emitter comes out to a capacitor. Goes to the resistor, 47.7. Oh, see, I can actually even move this around to make it a little bit better, I think. Wait. I'm just fucking it all up. What are these capacitors? What are these doohickeys? What are these guys? What do you say you are? What say you? Alright, I'm gonna turn this sucker off because I'm not figuring anything out. And that. Now I'm just questioning why this Chalky diode over here is so warm. Because I was looking at it earlier in the thermal cam. And I guess if I'm just trying to get this thing working, that's probably a likely suspect, but I probed it, tested it with the multimeter, and it seemed fine. So, I don't know. Oh, those are actually connected. That's interesting. So, maybe I should just finish doing the schematic. This is what I was working on last time. Holy crap. Now is this thing VDD? Yeah. The CT850. This is definitely a transformer. VDD as well. What is VDD? High voltage. VDD is supposed to be drain supply. Oh, that was another thing. I had it powered. His VGG was reading like 1 volt or something like that. That's supposed to be 0. So maybe we can dig through the VGG rail. Key drivers. Move all these into the group. I've got 2 of these. What? Okay, I don't know what the fuck that's all about. But okay. Is it VGG? Let me test that again. I guess I'll have to power it one more time. Ugh. There you go. That's our negative. This is our positive. Try to get these right. So what was it? It was between VGG and negative, right? Oh, I'm checking. Right. 1.3 volts. Yeah, what was it on the pins? 14. That's gonna be this one. VDD, right? Where's VDD? Is that this? It's 0 and 0, right? Yeah, 0 and 0. And then VGG, we should get 0 and 0 on these two. Like that. Because there's no difference between these two. Yep. And then what about VSS? There's that VSS right here, and opposite from the clock pin. Get 0 and 0, 0 and 0, and then let's measure VSS to VGG. 5.76 volts. We're about to ground. 7 volts. Okay. And then what about VDD? VDD is this actual negative. The VGG. What about VSS? 7 volts, ground. That. Okay. I have a good pentagram on too for VGG. Yeah, that's a good one right there. Okay. I feel like I just tried this, but I said that was a good one and then it falls off, right? Oop. Oop. Bruh. Man, I really need to get some better grabby doohickeys. Alright, stay for just like 1 second, please. And then this clock signal, right? Oh my god, I got rid of my measurements. Vertical voltage max. Give me that. I want that. Yeah. $5.9. Yeah, that's still acting like how I thought it was. i.e. doing nothing. So... Well, I think I might wrap it up here. Obviously, I gotta do a little bit more research. I want to clean up some of this stuff in Krita. Clean up some of this and double check some of these circuits that I've kind of done so far. And I want to test the clock circuit And maybe if I get a good working clock circuit, I can show that off tomorrow. But I do plan on streaming tomorrow, so if you want to see more of this, feel free to check it out. It'll be about the same time, more or less. Yeah, if I get a good breadboarded version of this, I will definitely share that and demonstrate that, because I feel like I want to test this and see how it's actually supposed to work. Maybe test it with my own transistors, just wire them up, find my own resistor values, you know, and then try it out and see what it does. So, maximum recursion depth exceeded. Ooh, that's fun. Nice. Anyway, thanks for hanging out. Yeah, thanks for checking this out, and you know, all that other jazz. If you want to see more of this, check out the channel. You check out the description. I've got some links in there to the Discord, to Patreon, all that other good stuff that you're familiar with. And yeah, thanks for watching. I'll see y'all later. Bye!